Here's how carefully concealed backdoor in fake AWS files escaped mainstream notice. Files available on the open source npm repository underscore a growing sophistication. Researchers have determined that two fake AWS packages downloaded hundreds of times from the open source npm JavaScript repository contained carefully concealed code that backdoored developers' computers when executed. The packages, img, AWS, S3, object, multipart, copy and legacyas, S3, object, multipart, copy, were attempts to appear as AWS, S3, object, multipart, copy, a legitimate JavaScript library for copying files using Amazon's S3 cloud service. The fake files included all the code found in the legitimate library, but added an additional JavaScript file named loadformat.js. That file provided what appeared to be benign code and 3 JPG images that were processed during package installation. One of those images contained code fragments that, when reconstructed, formed code for backdooring the developer device. Growing sophistication. We have reported these packages for removal. However, the malicious packages remained available on NPM for nearly 2 days. Researchers from Phylum, the security firm that spotted the packages, wrote. This is worrying as it implies that most systems are unable to detect and promptly report on these packages, leaving developers vulnerable to attack for longer periods of time. In an email, Phylum head of research Ross Bryant said img, AWS, S3, object, multipart, copy received 134 downloads before it was taken down. The other file, legacyas S3, object, multipart, copy, got 48. North Korea-backed hackers target security researchers with 0-day. The care the package developers put into the code and the effectiveness of their tactics underscores the growing sophistication of attacks targeting open-source repositories, which besides NPM have included PyPI, GitHub, and RubyGems. The advances made it possible for the vast majority of malware scanning products to miss the backdoor sneaked into these two packages. In the past 17 months, threat actors backed by the North Korean government have targeted developers twice, one of those using a 0-day vulnerability. Phylum researchers provided a deep dive analysis of how the concealment worked. Analyzing the loadformat.js file, we find what appears to be some fairly innocuous image analysis code. However, upon closer review, we see that this code is doing a few interesting things, resulting in execution on the victim machine. After reading the image file from the disk, each byte is analyzed. Any bytes with a value between 32 and 126 are converted from Unicode values into a character and appended to the AnalyzePixels variable. The threat actor then defines two distinct bodies of a function and stores each in their own variables, ImageByte and AnalyzePixels. If converterTree is set to true, ImageByte is set to AnalyzePixels. In plain language, if convertTree is set, it will execute whatever is contained in the script we extracted from the image file. Looking back above, we note that converterTree will be set to true if the length of the bytes found in the image is greater than 2000. The author then creates a new function using either code that sends an empty post request to CloudConvert.com or initiates executing whatever was extracted from the image files. The lingering question is, what is contained in the images that this is trying to execute? Command and Control in a JPEG. Looking at the bottom of the loadformat.js file, we see the following. We find these 3 files in the package's root, which are included below without modification, unless otherwise noted. Modified here as the file is corrupted and in some cases would not display properly. If we run each of these through the process image function from above, we find that the Intel image, i.e., logo1.jpg, does not contain enough valid bytes to set the convertTree variable to true. The same goes for logo3.jpg, the AMD logo. However, for the Microsoft logo, logo2.jpg, we find the following, formatted for readability. This code first registers the new client with the remote C2 by sending the following client info to 8520810829. It then sets up an interval that periodically loops through and fetches commands from the attacker every 5 seconds. Received commands are executed on the device, and the output is sent back to the attacker on the endpoint/post results. Client ID equals target client info name. The person or group responsible spent years working on the backdoor. Besides the sophistication of the concealment method, the entity devoted large amounts of time to producing high-quality code for open-source projects in a successful effort to build trust with other developers. In May, Phylum disrupted a separate campaign that backdoored a package available in PyPI that also used steganography, a technique that embeds secret code into images. In the last few years, we've seen a dramatic rise in the sophistication and volume of malicious packages published to open-source ecosystems, Phylum researchers wrote. Make no mistake, these attacks are successful. It is absolutely imperative that developers and security organizations alike are keenly aware of this fact and are deeply vigilant with regard to open-source libraries they consume. Please subscribe Cyber Jim Rachel.